Okay, this is a SUVAT question, a question all about constant acceleration. So for the first bit, we have a car and we're told its acceleration is constant at 1.83 meters per second squared. They give us the force, 1.870 kilonewtons, and we have to find the mass. So, what equation do you know that connects force, mass, and acceleration? Well, its force is mass times acceleration. Very famous equation, F equals ma. We have to find the mass, so rearrange for m. Therefore, m is equal to F over a. And just stick in the numbers in your calculator. So, the mass is the force. Now, we have to convert to newtons. 1.870 kilonewtons is 1870 newtons. Acceleration, meters per second squared, already in the correct unit, 1.83. Okay, stick that in the calculator and you get 1021.857 something something something, and it wants this to 3 sig figs. So therefore m is 1, 2, 3. Okay, so that 1 is going to leave that 2 alone. So it's going to be 102, but we don't leave it at 102 because it's about 1,000, right? So we have to write a 0 there. Mass, kilograms. And always finish with a quick check, is that a sensible answer? Mass of a car, about 1,000 kilograms? Yeah, that's sensible, it's probably correct. It is correct. Okay, that was 3 sig figs. Okay, next bit. The car accelerates from rest for 16 seconds. What is the speed of the car after 16 seconds? Okay, so it's accelerating, constant acceleration, SUVAT, 16 seconds. So let's write down what we know. SUVAT, S, SUVAT. Okay. Distance. Do we know distance? No, we don't know distance. U, it says it accelerates from rest, so U is 0. Okay, U is the initial velocity. V, it wants to find velocity, right? Yes, the speed of the car after 16 seconds. Okay, so that's what we want. A, acceleration. A. 1.83, and T, it's for 16 seconds. Okay, there we go. So we want V, we don't know S, and we know U, A, and T. So which of the SUVAT equations connects U, V, A, and T? It is V is U plus AT. Stick in the numbers. Velocity is U is 0, ignore it, AT, acceleration is 1.83 times time is 16. Stick that in your calculator and you get 29.28 meters per second. Okay, now it doesn't tell you to do it to a certain number of significant figures or decimal places, so it's up to you to be sensible. How about 1 decimal place? That seems sensible. 29, 2 significant figures, that's too much. So we'll say V is 29 the 8 pushes a 2 up to a 3, meters per second to 1 decimal place. Yeah, 1 dp. There we go. That is a sensible choice. Good. Right. This bit. Last question. They give you this velocity time graph. Okay? Now, immediately an alarm bell, or not an alarm bell, a bell should go off in your head. It's a velocity time graph. And immediately you should already be thinking, velocity time graph, area under the graph equals distance. Okay? Velocity time, area equals distance. And I bet you they're going to ask about that. That's what the bell should be saying. As soon as you see a velocity time graph, always think, bet you it's going to be about area under the graph is distance. Okay? Remember that. Not distance time graphs, velocity time graphs. The area under the graph is the distance covered in that time. Okay. Show that the distance travelled, of course, when the car is moving, a constant speed is greater than the distance travelled when the car is slowing down. Right. 4 marks. Easy. This is a gift. Okay? As long as you know that, it's a gift. So, distance travelled when the car is moving at a constant speed. Which bit is constant speed? Well, there's the velocity. Velocity and speed are different. I know velocity has direction as well as magnitude, but it's constant velocity, 16, it's this bit, okay? From there to there is the constant velocity bit. This bit is accelerating, this bit is accelerating at an increasing rate, this bit is decelerating, that's the constant bit. Now you have to read off these values accurately on your question sheet, and it goes from 15 seconds to 30 seconds, okay, at a velocity of 16 meters per second. So the distance covered during the constant speed, constant velocity section is the area under the graph, which is that, okay? Which is going to be that times that, which is 15 times 16. Okay, so that area is 30 to 15, or 15 to 30 is 15, and the height is 0 to 16 is 16. 15 times 16 is 240, distance is meters. Okay, easy. Can't believe this is 4 marks. Right, we have to show that that distance is greater than distance travelled when the car is slowing down. Slowing down, okay? Velocity is getting bigger, bigger, constant, bigger, bigger, bigger. Okay, it's slowing down from there to there. That's the deceleration bit. So it's slowing down from there to there. Remember, look at it accurately on your question sheet as to which point that actually is. If you read it across, it's 30 meters per second and it's 41 seconds, okay? So the area is this bit here. That's a triangle, so half base times height, half that times that. So it's half times that. 41 to 50 is 9. Height is 30 to 0. Half times 9 times 30. Good. And that turns out to be 135 meters. Easy. We have indeed shown that that bit, that distance covered, 240, is greater than 135. QED. Done. So just remember, velocity, time graphs, area under the graph is distance. That will save you a whole lot of headaches and get you a lot of marks very easily.